The concept of pH. pH is the negative log of the hydrogen concentration. In more simple terms, pH is the power of H. So if we think about water being decomposed into its ions, we would have H plus and OH minus. And it's in equilibrium. So if we write the equilibrium constant, we would have H, the concentration of hydrogen times the concentration of hydroxide. So K is your equilibrium constant, the W stands for water. Well, that value, being a constant, is always 1 times 10 to the negative 14. So no matter what, my two concentrations the exponent should add up to be negative 14. If you end up with more hydrogen than hydroxide, that's going to tell you if it's acidic or basic. When they're exactly equal, it's neutral. If you have more hydrogen, it's acidic. If you have more hydroxide, it's basic. So in our first example, we're given NaOH. OH is a base. So the concentration of hydroxide then is 1 times 10 to the negative 4. So my concentration of hydrogen has to be 1 times 10 to the negative 10. So that my exponents 4 and 10 add up to be negative 14 or 14. In number 2, it's telling me that I have an acid. So this is my H plus concentration, 1.0 times 10 to the negative 6. That means my hydroxide concentration is 1.0 times 10 to the negative 8. And this is molarity. Molarity is the measure of concentration. So 6 plus 8 gives me 14. So the pH scale, or the power of H, whatever that exponent is the pH. pOH is the power of OH. So P stands for power, and then you have H. P stands for power, and then you have OH. Now pH plus pOH has to equal 14. If the pH is less than 7, it's acidic. Greater than 7, it's basic. And if it's exactly 7, it's neutral. Alright, so some examples. Concentration is always 1.0 times 10 to the negative something. 1.0 times 10 to the negative something. And we measure concentration in molarity. This is an acid, so this is my hydrogen concentration. Well, the power of hydrogen then is the number of the exponent, 5. Well, 5 plus 9 makes 14, so my concentration must be 1 times 10 to the negative 9, which means my pOH has to be 9. That would make this situation acidic, because the pH is less than 7. In number 2, we're given hydroxide, 1.0 times 10 to the negative. Hydrogen is always 1 times 10 to the negative, and it's measured in molarity. So because it tells us outright that that is negative 7, I know my pOH is 7. pOH, the hydroxide concentration's exponent. Well, 7 plus 7 is 14. So my pH has to be 7, which means my exponent has to be 7. In number 3, I'm given the pH of 8. Well, I know that my concentrations have to start off as 1 times 10 to the negative something, and it's measured in molarity. So if my pH is 8, then my exponent for H is 8. Well, 8 plus 6 is 14. So my pOH is 6, which means my hydroxide concentration is to the negative 6. If we go back to number 2, this solution would be neutral because the pH is exactly 7. In number 3, the pH would be basic because the pH is greater than 7.